Jai Hind, viewers. We welcome you back to MRO Digest Forum's panel discussions. Today, we are going to be talking about the MRO of drones, an emerging technology, which is expanding and growing day by day, and with bringing in a lot of technologies. So, to talk about this, we have got two very eminent panelists. First, we have with us Lieutenant General TSA Narayanan, who was commissioned in December 1982 and has more than 40 years of experience in technology, education and training, research and development, MRO and administration. As Commandant MCME, he organized a national seminar on AI for prescriptive maintenance and also undertook large number of AI projects. He was the chief architect for demonstrating the offensive swarm drone concept during Army Day 2021 in collaboration with a startup. We also have with us, as the second panelist, Maj Gen Ranjit Ghosh, who served as the Additional Director General and Colonel Commandant of Corps of Electronics and Mechanical Engineers. A postgraduate gold medalist from IIT Madras in maintenance engineering, he was Chief Managing Director of an Army base workshop. At strategic level, he steered life cycle engineering support for Army's capital acquisitions, revenue procurements. Colonel Ghosh has authored books on global defense industries and technological bases, and is a strong proponent of disruptive technologies for defense transformation. So with that, may I first request General Narayanan to give his initial views on this very crucial upcoming topic, which is really we need to know as much as we can to be able to do the MRO. General Narayanan, please.
Thank you, sir. Thanks for the introduction. I'm going to talk about basically those drones which are called the quadcopter and hexacopters. I am not going to talk about fixed wing drones. Of course, the same thing applies. But why I want to talk about this is more is because fixed wing, Indian Army, when it procured, has got its own ESP. Engineering support came along with it. I mean, it's all structured. Some hexacopter and quadcopters have been recently inducted where there is an issue on MRO as such. Now, before we actually discuss the actual MRO part of it, we need to understand what all is there in a drone actually. A drone has got a large number of parts, we all know. It's got motor, it's got sensors, imaging, it's got a flight control system. Those flight control systems have gyroscope, accelerometer, magnetometers. They basically maintain the orientation, stability, maneuverability, and all. In addition to this, the large number of sensors for imaging and other things like ultrasonic, proximity, they enable the drones to capture images, videos, data, and all, and perform various tasks. It's got a communication system so that it can transmit data between the drone and the remote operator. It's got an obstacle avoidance system, so to detect and avoid obstacles during flight. So a combination of sensors do that job. It's got artificial intelligence and machine learning inbuilt into it. It's got a battery and power management system, so that big battery, it's got a motor or an engine to give a drive to that. It's got software. All these drones utilize specialized software, and it's got large number of microcontrollers, and there are different types of microcontrollers. There are different kinds of flight control systems. So all these constitute actually a drone. So now, if that is that, what are the challenges in MRO if we go on to make it? First challenge is the standardization. In these drones, there are nothing standardized. Every company comes with its own type of drones. If I buy one type of drone and it is, say, swarm of drones, I bought it, and I find that after sometimes I lose 4 of the drones, and I buy 4 more of a different company, they won't work with these. For that matter, if even I buy from the same company, unless they are not the same drones, they won't work. So the biggest problem is there's large number of different types of drones. As I said, there are about 8 or 9 types of flight control system itself, which they're not compatible with each other. So when you go on to have an MRO for drones, you have to understand that the variety is too big. So many types come. So when so many types comes, the problem comes is the availability of components. After all, drones has got various components. It has got a motor, propeller, flight controller, sensor, battery. So getting those components becomes very difficult after some time. Now, when you have so many types of drones, the diagnostic and troubleshooting itself is a big issue. So you have to identify and diagnose issues in drones. They are complex, especially because of the multiple factors will lead to some problem in a drone. So you require expertise in the drone system, in flight control systems, you require expertise in sensors, the communication modules, otherwise the data will not come back, the power systems. There are no diagnostic tools as such for these things. Software updates. These drones require have complex software and they require regular updates for performance enhancement. So if suppose tomorrow you have to reload the software, you should be able to reload it with updates. And for that, you have to have the same type of microcontroller. Calibration testing is another issue, which is have to be regularly done. Data security and privacy. You see, these drones keep on passing data. So when they come for your maintenance operation, whatever data which is there inside this, that has to be ensured they are secure. And training is another big issue. You should be able to train your people in handling of drones for effective repair and maintenance. So if these are the challenges in MRO, then as I said, what are the technologies which are there in a drone? So the big parts could be the antenna, the airframe, the propeller, the motor, the flight control unit, the onboard computing boards, the microcontroller. There are so many types of microcontroller. About 8 to 9 types of microcontroller get used in drones. If you take Raspberry Pi itself, there are 5 or 6 types of Raspberry Pi, which is one microcontroller. So it is not that one is replaceable with other. So this is a big challenge for us to to do MRO on this. The camera, the engine, there are various types of engine. The drones also has got various category, 5 kg category, 10 kg category, 25 kg category, 50 kg, 100 kg, like that. So the motor and the gear engine, they all become bigger and bigger as the capacity goes up for loading. Similarly, the landing gears, there are so many accessories which are there. They're all technology intensive parts. Now, when you talk about MRO, it's also that drone is like any aircraft, I will put it that way. So you need to ensure that you treat it like an aircraft. You treat it like any aviation hector which treat. So you need to do a pre-flight check before you launch the drone. So what will you do in a pre-flight check? You will check the landing gear. You will see the propeller tightening. All connections will be again checked for the sensors and everything. Battery and voltage ampere check will be done. The payload mechanism, their gripper will be checked. Whether the camera is integrated, not integrated. The wind factor will be there, so wind speed will be checked. So there are some power on checks which are there in drone. That will be checked. If it is an engine based, the coolant and other things which are required to be checked, that needs to be checked. And drones have to be placed on even surface. They should not be placed on non-even surface. And there's a 40 parade which we do it for aviation, need to be done for drones also. Similarly, when the drones land back, you should do the post-flight check also. And generally, mostly the faults which will come will be on the avionic malfunction. The power plant, which I say, if it is engine based, there will be a problem with respect to engine. And most of the engines are carburetor based. Most of our mechanics must have even lost the touch of carburetor now. So, and if it is battery, if it is motor based, then motor issues will be there. The communication issue is always there. The communication modules frequently fail. Reloading of software is another factor of MRO which we have to do, which needs to be constantly done because of various issues. And then airframe related faults, it could be propeller, it could be anything. So, what is the biggest issue? Biggest issue in this is the standardization. When I say the standardization, the basic flight controller, there are 7-8 types. The microcontroller, which are there are 7-8 types. The motor which are put, there are 6-7 types. I'm only saying the common drones which are there because these commercial drones are being modified for defense purposes. So these are the various types which are there. So it is not that, if I make someone an expert in one type of drone, he will be able to repair the other type of drone. No, each module is totally different. So the concept of user repair, user has to be trained to actually fly these drones. It is not that you can, detail 2 people to please fly this drone. It is not like a kite flying. There's a DGCS certified flying course, which DGCS does, the flying schools which have been adopted, which have been opened, and the user should be able to fly these drones. Otherwise, we find that large number of accidents take place on these drones. And there has to be an O and I level repair, which has to be taken on by the MRO people. The D level repair can be with the OEM. Warranty repair is something which we have to ensure, because that is where the OEM tries to blame the user for it, that it was because of mishandling, the drone crash or whatever it is. And sometimes we have also proved that it was because of software malfunctioning, the drone has crashed. So our people should be able to set a carburetor, repair the motor, and of course AMC is always there, which if they are not able to take on as part of the MRO, then AMC should be taken. So basically what we should look at it is O and I level should be taken on by the maintainer, user and maintainer together, and the D level should be on AMC with the OEM. Now, if these are the constraints, then how do we train our people for this MRO of drones? So there are a large number of training modules which we will have to develop to train on these drones. Other than the practical and the theoretical training which we give them, we should be able to give them training on signal communication, what are the modules which are there, the map loading into the drones, the software and configuration files, how to do it, loading and changing as per requirement. Training on the hardware to include disassembly, assembly, calibration, replacement, and training on software to include loading, unloading, troubleshooting, port and IP configuration. Now, this port and IP configuration is very important. If I take Raspberry Pi, as I said, as a microcontroller, it's got 7-8 types. Now, each one has got different types of ports. So when you write a software, you will say the data in out will be from the port number 4, say. And if in next microcontroller that port number 4 is not for data in out, then the software will not work. So this is the biggest problem. So the maintainer has to be very clear what all is there in the drone, and it should be, we should understand how is this software being configured. Whereas in other systems, if you take any other our defense system, the software, we do load the software, but we don't ever bother to look at the port and other things for one reason, because the hardware which comes is supplied by the OEM and it is the same hardware. But in this case, these drones technology is changing so fast, the hardware is also changing very fast. You may not be able to get the same hardware. So this is my prelude and introduction to drone, technology issues with respect to MRO. Now I'll request we can discuss each issue one by one. Thank you.
Thank you. In fact, your experience, rich experience, more than 5-6 years as we were discussing, and your deep involvement with drones is coming through very clearly with the intensity of knowledge and information you have just shared with us. It's quite amazing. So may I now request General Ghosh to give his initial views?
Thank you, sir. As far as I see the MRO of drones, I would try to simplify the whole process, because there are 2 types. If we may have to go into the 2 types, that is the rotary wing and the fixed wing. The rotary ones are very small, miniaturized one. They may be nano or micro, small, mini, and up to. So that's just about 150 kg, below 150 kg or so, which is at the quadcopter form or the hexacopter form, or but they are very simplified models commercially getting used. They just comprise of a landing gear on which it is landing, plus it has got a place to pick up the battery pack, which could be lithium or any of these rare earth batteries as it keep getting defined. And it has got the motor and its swing arms and the propellers, and of course the main aspect of the payload. So in its simplest form, these quadcopters or rotary wing or tactical drones have just costing roughly around $500 abroad, or maybe in our case it will go up to about, as of now, indigenous ones are around 5 lakhs plus, whereas the Chinese ones are much lesser. But in all these things, what we find is in the quadcopter or the rotary form or the drone form of the basic drone form, which we're talking, there is not much of a maintenance, repair, or overall aspect into it. It is more of replacement rather than any kind of repairs, I would say, because the cost of replacement is going to be much cheaper vis-a-vis the cost of repairs for the lower category. You come on to fixed wing ones, it's a different story altogether. Now the sophistication which Gen Narayanan has brought out is very much there, but all these flight controllers, drivers, the communication units, and the modules, other modules which we are talking about, the sensors, they are surely important facets. But as of now, the costing is such that if you want to set up the MRO facility, if you want to standardize it, there is too much of proliferation. It is happening in exponential terms. The obvious reasons are the cost factor. Obvious reason is replacing that famous pilot who is going to, if you do the pilot in what the US had faced with the Russians, or subsequently if you do the UAV in the hands of the Iranians, it has got a reverse edge of what will happen. So it is going to evolve. There are going to be better systems which will keep coming in. There will be AI or a much better resolution sensors. There will be much faster computing. All that is okay. But I feel the rotary wing ones do not require. Coming on to, because it's a very simplest form of things, propellers can be replaced. In fact, when you open that kit of any of these smaller ones, you get additional propellers packed into it. Only the problem is the DC motor, which is X, in case of Indian, it is X import. So there itself we can have a substitution to that motor rather than doing anything else. The battery pack has got a life. It can be 2 hours, it can be 16 hours, depending on what is the type. If it's a mix of fuel and this thing, you can extend the endurance. But in these smaller ones, it is not of that category. Coming on to the next category. The next category is that is the fixed wing ones. Now, fixed wings are also coming in diverse varieties. If the functions are different, if it's for spying or surveillance and recce, it has got a different composition of things. If it is for stealth purposes, it is different. If it is for killer predator types, then it is completely different. Now, if you are looking at scanning a particular area and keeping it under observation, you're going in for, the US is going in for much advanced ones. They're having advanced next generation sensors, which is having much higher resolutions to come in. Those are sophisticated fixed wings one, which requires certain amount of MRO effort. How that MRO effort will come in will depend on the population of that equipment which is with you. How much is it the civil military mix? How much are the numbers? Is the numbers making it profitable to put in your OID level repairs? The operator level will continue. Operator level will have, it is not operator level is so simple. It is a merger of operator and the intermediate levels, as at least our experience in the army has gone, because the sophistication involved is more the test equipments required or the machines required to do it or do up the processes, either to replace it at the LRU line replaceable units level, or to diagnose and rectify it and then replace it through the shop replaceable units. It has to be done as a merged echelon of operator and intermediate levels in this. The depot level has to have, it has to be concentrated because of, if there is a standardization. If there is, while Narayanan was talking about more of quadcopters and all, which have totally proliferated in the environment, with everyone coming into the fray, there will never be standardization in that. But in your major weapon systems, if it is for military weapons, weapon platforms, weaponization or otherwise of the drones, then in that case you have to look at the total numbers in your country. You have to look at the total numbers in your military between the three services, and then you have to plan what kind of O-level setup, O and I-level setup has to come in, how many repair points have to come up, how many sets have to come in of either the ground test equipment or ground handling equipment or the technical GTSC, that is, that numbers will come in accordingly. Then what has to get into your depot level will have to be decided. How much of it is being given is the second part of it. How much will go to the factory level or with the OEM if it is export, if it is indigenous, ideal, but we are nowhere around that. Today, everything is more or less imported in terms of DC motors or the flight controller or the other aspects. So we are still sort of mushrooming as of now. So these all things will dictate as to what kind of maintenance philosophy has to be adopted. Is it going to be a OID and factory, or is it going to be OID, factory plus OEM premises? Is it going to be a rate contract? Is it going to be a AMC? Is it going to be a tri-services AMC? Is it going to be a single service? Is it a civil military AMC? Because cost will come down. So this is how the whole maintenance philosophy of MRO for fixed wing will matter, and how the rotary wing will matter. That is how I see it. I am not that well familiar as Gen Narayanan on this aspect. And there are a lot of electronics, a lot of microcontrollers and others. Yes, they are sophisticated. They are commercial today. When they get ruggedized and get into the military form, then it is a different case. And that will take time. It is still graduating. I think those are the initial thoughts on this.
Thank you. Thank you. I think General Narayanan wants to say something. Go ahead, General Narayanan, please.
Sir, I only want to say that it is the commercial drones which are being adopted, but they should be able to, they have large number of sensors for various operations which they have to do. So that's why they are very costly. Now, these drones, because they carry good payload, maybe 15-20 kg. So instead of motor, they are based on engines. So when we operate these drones, these engines do go bad as any normal machine. So you require people to maintain. It is not that everything can be replaced. You can't replace the engine. So that kind of engine is not available. So direct replacement. So you require your people to be trained in O and I level, even if it is a small drone quadcopter or hexacopter, because of the cost involved. Because all this cannot be sent to OEM every time for a repair. The D level, yes, that can be, for various card and all, D level repair, bigger repair, it can go to the OEM. But for this hexacopter and quadcopter also, the maintenance people have to be trained for their repair. And regarding fixed wing, we have already a format in Apora PME. So I think that kind of system can be, continued. There's nothing wrong with that system. That is fully functional system. That can be continued.
Thank you very much, General Narayanan, for the bringing in that aspect. The what from a discussion which just now you have said, from there it emerges that firstly the questions of standardization, modularization, and the one advantage is the drones as a system, the number of components, like they are, I think they are not like a normal, very complex, like a tank, there will be relatively lesser number of components. That sort of allows. And the issue of interoperability. If you can club all these together and you could give some, like for example, if you have got different types of motors, for example, I'm just taking hypothetically, at least the couplings could be similar. See, I'll take in the case of electronics, what is happening is like the standardization of certain elements of different makes, that sort of a thing. Do you feel there is some strength in this, that if some amount of standardization of such issues is carried out, that means if we do too much standardization, then you are fixing one particular type of component from one particular provider, which goes against competition. So we must allow competition, and within that, can we do some standardization? Is it possible to produce a document like that by anybody? So that's so. General Ghosh, you please go ahead.
Sir, the point of standardization and interoperability is more or less addressed in the case of fixed wing military applications are concerned. For military applications are more or less three across the thing is more or less same. It may extend to your MHA and others also subsequent. So the family of things will come up, the standardization will come in, the interoperability of modules will be found, the plug and play system will come in. There are connectors which are already, the construction is such that they are all supposed to connect and be disconnected within the each of these parts. Let it be the gyros or any of the aspects which Gen Ranjit and photo. That is as far as the interoperability and this is concerned. Secondly, what is not available in the country, what is available or what is our strength today is just the frame. That is the architectural or the structural aspects. We carry out NDT, we are doing certain repairs, that part. But the payload is a complete black box. With the Make in India effort, we will have the foreign OEMs of certain other subsidiaries of the prime who's been supplying all this, they will get into some collaboration into JVs or in some kind of subsidiaries which will come up, which is happening, but it is taking time. And thereafter, you will have this transfer taking place. At the same time, when you diversify your fleet from one OEM to the other, there will be certain amount of technologies or acquisitions and technology transfers by those OEMs. Once they supply you a particular military application UAV, they will set up shops here. So that technology will also come to us. So accordingly, once the production technology comes in, yes, I do not agree that the maintenance TOT or the MTOT should overlap over the, or the production guys should do the MTOT also, because of obvious reasons. But at the same time, initially, the beginning has to be made. The beginning will be made through these methods. And that is how I see it.
Gen Ranjit, please, you wanted to say something?
Sir, regarding standardization, the problem with drones was we were importing everything in drones. When I say we, the Indian companies, were importing everything of drones. So they were not manufacturing, they were only integrating it in India. So that is why whatever they could lay hands all over the world, so they used to buy. You'll be surprised that, even things like lithium ion battery pack is also imported. I mean, that is not made in India. So we wanted to try from Israeli one, we wanted to try from Taiwanese. I mean, finally we found out the Israeli is the best and Chinese is the best, the worst category. Similarly, we did not have anyone producing a small engine also in India at that time. That is also being imported because when the engine, we could not get the part. We tried from a Coimbatore firm which was making small engines, but I did not succeed that much. What I'm trying to say, unless the Indian industry does not develop, if you are going to be only integrators of these drones, then it will be very difficult to standardize. So unless they develop their own technology, their own drones, everything, including making a BMS for a lithium-ion battery and making your own engine, making everything, making your own motors. Today, even for all the motors, the require certain things are imported. All motors are not made in India. Brushless motors, things are imported. Even the magnet which is required is imported. So I'm not saying anything wrong with that. But what I'm saying is if we require standardization, then the thing has to be made in the country. Then it's only possible that, we can go for some sort of standardization.
Thank you for that. That actually brings me, because honestly, I feel that if you are integrating something, then you're pretty good. Because it's not easy to create a system even after integration. I would say that means we have reached somewhere. And kudos to the people who are doing it. I wish them well. And the other day, I attended a very nice seminar, which was conducted by, one of our members, Mr. Pradeep Gupta, by his think tank, that is Strategy and Policy Initiatives. Over there, a gentleman, a professor who came and spoke about agriculture drones. So, what I feel is that if you look at the way the agriculture drone is required to work, even if, let's say, it's a particular area, it is just spraying something, it's got to be a pretty tough drone. It's like it's got to do its job, come back, get maintained, go do it again. So I think there is, do you think there is a there is a chance here that we look at what is available in the agricultural drones area, and then we see how that can be brought in here. And you don't worry about the fact that some things are getting imported, as long as the supply chain is there and you got alternative supply chains if something gets choked off. How does it matter? Like I famously said that during the Second World War, the Sherman tank, which we also used in 1965, has 4 engines. What does it matter? As long as the engine, it will run. And normally the engine is the most crucial part, as it's come in the discussion here also.
So,
Sorry.
Sir,
Go ahead, General Ryan, go ahead.
The agriculture drones, their height, so flying height is hardly anything, sir. They fly at 50, 100 meters only height. Most of the commercial drones do not fly high. Our drones have to fly high to be away from the small arm ranges, away from AD guns. So our biggest problem is this. So when we fly very high, the control of drones becomes very difficult because of the air turbulence and all. Second thing, when you talk about most of the drones, actually in the initial stages, could not fly more than 5,000 meters. They used to fail miserably. Now the drones have started where they have been able to do it. So our problem is height, sir. So that's why we cannot use any of these commercial drones.
Yeah, General Ghosh, please go ahead.
Coming on to the aspect of system integration and cross drone utilization, sir, I think we should, again, I will reiterate the point that the maintenance philosophy depends on, if it becomes a high cost, high population equipment subsequently. It is a high cost as of now. If we go into the cost wise, if you are saying the tactical drones, as I said, is about $500 or about 5 to 6 lakhs in Indian guy, or a Chinese one may be cheaper comparatively to about 2 to 3 lakhs. Whereas the other ones have gone anywhere between 10 to 12 lakhs to about 500 lakhs today, as far as depending on the sophistication as it is coming in. So cost wise, this is one aspect. It is a high cost equipment. The high cost, till the time it becomes high population, this kind of a complete MRO structure will come up. By that time, system integration will convert into system indigenization over a period of time. And by then, you will be able to sort of make inroads in terms of all these things which are getting imported. Because the numbers will speak. It is volume of sales. It is the scalability which is going to impact. Second is the requirement of the drone. Now, what is the requirement for the tactical drones is on the borders. It is on the LC. It is across, looking across. It is got a very small pop. It requires faster response time. It will take off in 30 seconds rather than all these preparations of the bigger ones to get it prepared itself, and by the time it takes about 2 hours. So, and it is looking at cordon and search there. You are looking at the hovering around that area and seeing no chap is no insurgent or no guy within the cordon or is going into the outer or the outer to the more outer ones. So that is the whole essence of your tactical drones or your strategic UAVs. And so does the cost, so does the product, and so does the interoperability and the MRO philosophy and the indigenization from system integration goes.
Thank you very much for that, General Ghosh. In fact, I must say that though you must have said it before also, but I heard this very nice term you used, system integration to system indigenization. This has to be, I think, very much a focus of one of our panel discussions, because I think what you have just termed, this term you have used, I totally believe in this. It's the way to go. If you look at the world over, everybody has done the same thing. Like everybody is looking at technologies and then developing them. And system, if you are integrators, you have already more than half the way you have crossed. And as I said, as long as supply chains don't get blocked, it doesn't matter, you can change a component. But now the next question, which will be my final query, after that you can give your sort of closing remarks, and then we have got participants, they can ask questions if they want. So I'm going to club it all together. And what I'm going to say is that there seems to be one thing which is evident, that unlike our normal land systems, this being an aviation system, it can come back to base. Now that means when you come back to base, that means you can create a pretty good collection of technicians over there. And we know our good technicians can do wonders, like they are very good learners. And having said that, what is it that we should say which can create a flexible MRO which can take on virtually anything very, very quickly? Documentation is now available. The one advantage of coming back to base is that the communication will be also better. So documentation will be easily. Virtual guidance is easy. All these things can be factored into the contract. And clubbing this with the other issue of the leveling cost, which Brigadier YVR Vijay talks about, which is also another very seminal idea which I got to know through our discussions. So the leveling cost, which General Ghosh also sort of mentioned, the volumes and maintenance costs and at what stage leveling cost comes in. So these things getting mixed together, how do you look at, generally speaking, if you could say, aspects of MRO where we have a flexible MRO with warranty, with PBL, with some amount of stocks of spares being kept for critical items, all these things, what would be within our for want of a better word, within our constraints, I would say, or within our abilities, what sort of a facility you think we can create which will be able to address the various challenges literally on the fly? So, General Ghosh, go ahead, please.
Sir, I think we can take a clue straight away from the present system itself. Caters for all the three aspects of a flexible MRO, performance-based, and also redundancies. Because when you go in for this OID model, at the operator level, you are having replacements available. And the entire system of aviation supply chain is always on the concept of repairable being made available first before the replacement being made available in situ before it can be replaced. Because what is it called? Airworthiness and air availability or availability of assets is more critical. So that redundancy is there in O and I level already. Of course, the turnaround time in the second phase of where you're pushing it back to the factory or the OEM, if he's outside and he's not set up the shop in India, then your turnaround time increases and operational availability gets impacted, for which you have the AMCs kicking in. The AMCs will have to have, they can be made more stringent in terms of the availability factor. You want 90% availability, 95%, 100%, cost will go up. But AMC will be depending on what is your criticality of that particular asset in terms of the thing is concerned. As far as performance-based incentive is concerned, once you start identifying which are the low-tech ex-import items which can get start with the indigenization, you start pumping in for that PPI performance-based incentives to the workers to indigenize that particular thing, like what Jan Vijay had mentioned for the solar aspects. And as far as the number of floats is concerned, what kind of redundancy will depend on the criticality of the equipment, the cost of the ABC, what we talk of. ABC analysis will dictate what should be the stocking levels. That's it.
Yeah, General Ryan, would you like to say something on these aspects?
Yes, sir. Sir, regarding this aviation model, it is there for the fixed wing only. It is not there for the quadcopter and hexacopters as on rail. You require your own EME technician to be there, who should be able to do the basic repair on these drones, and he should be well trained for that. And at present is the basic repair they're able to do. And if there's anything major, then they are contacting the OEM. So that is where we can actually have the OEM, developing augmented reality for his drones, so that our mechanics sitting in field, internet connection is there and can, there only, so that you don't waste time in sending this drone back, and is able to, he can say, okay, this part is required. Once he's able to, open and see, and that part can be couriered to the nearest army establishment where the courier can reach, and after that can be collected by the army, so that the turnaround time can be decreased in this way. Otherwise, very difficult, for the drones to go back to the OEM, get repaired, and then come back. So these are the things which can be done, but we can enhance the repair capability by putting as part of the procurement only that augmented reality package will be developed by the OEM for repair purposes. So that if there is anything that we can take the help of OEM, and they know you cannot stock any spares in the workshop, then small maybe battery and all not can be kept because we don't know what is going to fail, and neither he has got any analysis because he is also imported. So that he cannot, OEM also cannot say that what should be the MRLS. So very difficult. So it will take us some time actually to make our procedure correct for these kind of drones, basically quadcopter and hexacopters.
Well, thank you very much. Now, with that, actually, we are toward the end of the panel discussion today. But if any one of the participants would like to ask a question, they're welcome. They can go ahead. Yeah, go ahead, Sonal.
Sir, I have a question on the maintenance regulation framework for drones, sir. Now, for the defense military use drones, I'm sure the military, when it is inducting, it's making a maintenance framework, the regulatory framework, what quality of maintenance is to be ensured. But for commercial use drones, which should, in my opinion, should be a different category altogether. Um, it the kind of commercialization that is taking place tomorrow, you'll have even signal boosters to mobile systems and all that kind of drones that will come up, and they will be repaired. They'll be like repair shops that will mushroom, something like mobile repair shops or something like car garages that will mushroom. They'll not be authorized. They'll authorized OEM centers, but there'll be civil shops that will come up for these commercial use drones. There has to be a framework, maintenance framework for such kind of they're part kind of MROs, small MROs, in my opinion. So the airspace regulation and all that is coming up for drones. But a drone is finally a flying object. It's a missile if it is uncontrolled. So a maintenance framework also has to come up. Like the aviation has a very regulated maintenance framework. So for drones also, this kind of framework should come up, sir. So I will request your opinion on that, sir.
Yeah, go ahead, anyone.
Sonal, as far as the drone industry is concerned in India today, I think it is very, very nascent. There are about 400 odd assemblers today in India. But the problem is very few things have been clarified. Maybe that red, yellow, green zones are where you're flying. That is one part. The certification by DGCA is second part. The certification not being accepted by the US federal that administrative aviation administration or the European Union counterpart is the third part. Fourth part is what is the level of MRO application of by the drones for MRO applications. That has also been halted after 2017 and not made much progress because of certain regulations within the US, which does not permit utilization of these bigger, more than 250 kg drones into this particular field. So these regulations and all you have to come up with a national drone policy first as to what are the types of drones, what is the routing, what is the certification, what is the operability, what is the counter drone aspects of adversary trying to launch in. All these aspects have to be looked into. Thereafter comes your construction or manufacture of drones. What kind of IPRs, what kind of localization or reduced proliferation in terms of authentic suppliers and quality, more than authentic, quality suppliers and other things. These all things have to get drafted. There is a particular forum which has got created. I was interacting with someone, but that is very, very, very nascent today. But yes, problems have got identified. What is this drone industry looking at? And it has happened because Make in India is being pushed. Moment till now, what were they doing? They're just bringing it from outside and just doing, and then anything which was cheaper outside was being pumped in. It was more of a dumping which was going on as far as drones is concerned. So it has to be a much more holistic approach. It has to be a much more comprehensive approach.
Gen Ranjit, would you like to say something?
Yeah, I want to say, sir, the most of the commercial drones, what he is talking about, are used to less than 400 feet height, which is a green zone as such. Unless it is over a military establishment or an airport or something, there are some stipulations are there. So, and you don't require a license to operate these drones nowadays. And it has become very easy now to acquire drones, fly drones, So most of these commercial drones, their usage are below 400 feet. So there's no issue with respect to those regulations of DGCA as such. Now coming to the repair part of it, these drones, the OEM is able to repair. But as you say, yes, if sufficient drones come the way mobile proliferated, if these kind of drones proliferate in that amount, then you will have corner shops repairing drones in India without any problem. That will come up. I have got no doubts about it. But for that, the volume has to come up. The volume is not there for drones as on date. Of course, companies are buying, people are buying drones, but still, you do not have in India Amazon delivering package to you through drones. That is still not yet started. Let that start. Maybe what you're saying will come up.
Thank you very much, Gen Narayanan. I think we could also talk at length about right to repair, leading on from what we just talked, but maybe that's for another day. So with that, viewers, we come to the end of today's panel discussion, and we look forward to having you back for our future panel discussions. If you want to contact the panelists, their profiles are there. The links to their profiles are there in the show notes, and you're most welcome to contact them for further guidance. And we look forward to having you back to listen to our future panel discussions in other formats which we have. And once again, with thanking both the panelists and the participants, I bring this particular panel to a discussion to a close. Jai Hind.